Probability distributions have different types, different ways that the distribution of your data will look based upon the nature of what you are testing for. The most common one, as you can guess, is the standard distribution. This gets termed as the bell curve. And what it is there's data points that are similar and they occur within a very small range. The vast majority of the points in your data that you will get tend to appear somewhere roughly around the average. So if you're looking at the chart over here, you see the highest distribution of probability of that event happening is somewhere around the middle, the average, the mean, if you will. There'll be very few outliers. Very few points will exist more than 3 standard deviations below the mean or 3 standard deviations above the mean. So what business aspects would look a little something like this? Risk models, the probability of particular events happening, like a default on a loan that you made to somebody. There's not going to be a very widespread range right here between the different customers that you have. Most people are going to exist somewhere in the middle. Process variations could be the element of manufacturing. It's going to look pretty similar from period to period. So the number of units that you make in a period isn't going to range all over the place. You're going to have a number of units produced that's somewhere around the middle. Same thing with employee performance. How fast employees get the job done is going to be pretty consistently a normal number, somewhere around average, with very few points that are far away from what is the acceptable mean. So for a standard distribution, whatever your x-axis is down here, whatever you are measuring in this instance, is going to definitely be something that can be measured on a pretty large scale. Now, it's not going to be like the world's biggest scale, but it could be like money spent on utilities during a period, units produced during a period. If you're an outdoor establishment, the temperature outside during a period. Like, you're not going to have a crazy range. It's going to be a pretty tight range of numbers that get returned. Another type of distribution is binomial distribution. And binomial means 2. So it's based upon an experimental sample size where there's only 2 possible outcomes. This one's a little absurd, but I'm going to go with it anyway. It's the probability of getting your 5th, 6th on a specified die roll. Well, there's only 2 outcomes you can have there. You rolled the 6 or you didn't. So binomial distribution is just that. It's the number of instances where it takes for something to happen, in this case the die roll, when there's only 2 possible outcomes. You roll the 6 or not. And in these instances right here, the first trial doesn't affect the likelihood of the second trial. Like, you can roll a dice, and if you hit a 6 on your first roll, it doesn't change the chance of getting a 6 on your second roll. You still have a 1 in 6 chance. So how does this work in business applications? Defective inventory. You produce a piece of inventory, either it works or it doesn't. Payment defaults can happen in here as well. Did they pay you or not? In marketing effectiveness, if you ran a campaign, did the customer buy your product or not? There's only 2 possible outcomes in here. And then you get all of the different probabilities based upon certain, elements of that yes or no condition happening over and over again. So if you had a marketing effectiveness that had 1,000 people that you sent out an email to, hey, use this discount to buy a product from us, the returns you would get would how many people out of that 1,000 returned that email and actually bought the product. So binomial distribution doesn't have to center around an average point. You'll typically see a spot, somewhere in there that's bigger than others. The most likely outcome is kind of the way that probability works. But from instance to instance, this thing could take on a much different shape. Sometimes you'll have one high central point, and then it'll drop down pretty fast. Sometimes it'll be really wide and flat, depending if you have a wide range of potential outcomes that you have in there. And also within this, you may have a tail, if you will, a skew that is very far off to one side or the other. So binomial distribution, higher chance of outliers. Within that, it's just the way that things work. Poisson distribution is very similar, but it's measured over a period of time. So in a Poisson distribution, you are going to have something happen per a unit of time. In the case we have here, the number of calls that customer service took every minute during the day on average. Well, we have a probability for each one of these states. And the probability, like in this case, of 2 calls being average per minute is about 22.5%. The same thing is with 3. For 4 calls a minute, it drops down to like 17.5%. For 5 calls, it's just 10%, so on and so forth. So you can use a Poisson distribution to measure things like customer traffic per day, measurement of time, inventory purchases that you need to make per month, and then also temporary workers. As a measure of time, you may have a period of time where you need more staff than you actually have at the time. Growing up, when I was in high school and in college, I worked every summer moving furniture as a temporary worker. Why would they need temporary workers over a period of time in the summer? Because that's when people tend to move. They don't want to move during the school year and uproot their kids. They wait until the school year is over and they move in the summer. So going through and figuring out how many temporary workers a moving company would make is dependent on what period that you are testing for. In this case, if it's in the summer, the probability of needing a higher number of temporary workers is going to be much higher than the probability that you would need in the winter.